All right. Hi, everyone. Happy Tuesday. Still not feeling 100% and staying home with this one as well. So today's video really shouldn't be anything too long because I don't have to write anything. So we're just going to go over what we did yesterday. And then the rest of class time should just be time for you to work on multiple choice and free responses. I'm going to turn the video off, but if you hear anything, that's just Sienna making a noise while I make this. At least maybe I can't turn the video off now that I did. Okay, well then you get this for the next 5-10 minutes. All right, yesterday we talked about how to find how many standard deviations you are from the mean, specifically above or below. And the way we do that is using a z-score, which is the same thing as called either a standardized test statistic or a standardized score. You do get the formula for z-score on the AP exam, but it does not look like the formula that I'm giving you, which is value minus mean divided by standard deviation. It looks a little bit different. For now, you can use that formula, and then when I get back and we start to get into more complicated statistical fun things, then the formula will slightly change. If a problem ever asks you to interpret what the standard deviation means or what the z-score, means, you'd want to say context. So whatever you're talking about is whatever the z-score, standard deviations above or below the mean. So if you have a negative z-score, that means that is that many standard deviations below the mean. A positive z-score is that many standard deviations above the mean. The second thing we talked about yesterday was what happens to our distributions when we change the data by either adding, subtracting, or multiplying and dividing. So when you are adding or subtracting data, the shape stays the same and the variability stays the same. Variability is going to be things like range, standard deviation, IQR, all those types of things. But the center, either your mean or your median, is going to increase or decrease depending on if you are adding numbers to your data or subtracting. For multiplying and dividing, I'm sorry, I don't know how to move my little head. Oh, now I can't go. You can go back and pause it. I don't know how to go back to the previous slide. I was going to try and move the little circle so that you could see what it said, but I think you kind of hopefully get the gist of it. Okay. Here is the answer for number 1 for the check your understanding. Eleanor's z-score should be 1.8. Gerald's z-score should be 1.6. Based off of that, you should be able to determine who had technically the higher test score. I'm going to kind of leave that for you to make sure that you understand if you have a higher z-score, what does that mean in regards to what they scored on the ACT. For this second problem here, we have the dot plot and we have the summary statistics. So if you convert the cost from dollars to cents, thinking about what kind of a change that's going to be from 1 to 100, no matter what you're doing, the height or the shape is going to stay the same. It'll still be skewed right. However, since you are multiplying, to go from $1 to 100 cents, that conversion is multiplication. You would just multiply the mean by 100 as well, and you would multiply the standard deviation by 100 also. Let's see if I can make her happy. There you go. You want this? For the second one, if you are increasing the cost of the ride by 25 cents, that's going to be adding, and so the shape once again would stay the same. Continuing off of the part like 1 that you've already converted, you would shift or add 25 to the cents that you already have. Variability, though, does not change. It would be the same variability as it was before because variability only changes by adding or by multiplying and dividing. So the standard deviation would be the same as it was from part 1. For number 3, the shape once again would stay the same. And if we're changing everything to z-scores, for a z-score distribution, the mean is always 0 and the standard deviation is always 1. We'll talk about that a little bit more on Thursday and Friday, why that is. All right. If you don't have any questions about that or anything, then you can go ahead and have Mr. McKenzie pass out the review assignment for today. You have 6 multiple choice questions. and 2 free responses. Remember, multiple choice for the AP exam should take you no more than 2 to 3 minutes. So technically you should be able to get these multiple choices done in about 15 minutes. And then same with the free responses. I took the free responses from past AP tests. So the number 7 is from the 2017 AP exam, and number 8 is from the 2016 AP exam. So the wording and everything like that is very much like what you will see in May when you take the test. These both should take you about 10 minutes per problem. I think 10 to 12 is technically the amount of time you get. So really you should easily be able to finish this assignment if you're using your time wisely before you leave. Obviously, you can use a calculator and everything, and you can talk with the people at your table group. We'll go over the answers. I will be back tomorrow. I just have a bad cold, so I just needed one more day. But I should be back tomorrow, so we'll make sure we go over all the answers there. On Wednesday, when I get back, you will have a practice quiz. I'm calling it a practice quiz again because I've been sick, so I don't think it's fair to have you take an actual quiz since I've been gone. However, because of AP pacing, I really can't afford to lose any days. So instead of it being a normal quiz, it'll be a practice quiz like the first one in the first chapter. We will eventually take real quizzes, but because I was sick, another gift to you all. So that will be on Wednesday. If you need anything though, feel free to email me and reach out. But otherwise, that's it. You say bye, Sina? Say bye-bye. Bye.